In this video, we're going to be explaining lesson 4.9 and 4.10 redox reactions. We're going to be explaining them in the same video since they are heavily related. So the main basis of this entire chapter will be focused around oxidation reduction reactions. So an oxidation reduction reaction is any reaction where there is a transfer of electrons. Oxidation reduction reactions, or shortly redox reactions, can be separated into two different components. First of all, oxidation, which involves a loss of electrons, and reduction, which is the gaining of electrons. You can simply memorize this by remembering the term oil rig, which means oxidation is losing. Here we're talking about electrons, of course. And reduction is gaining, again in electrons. One thing to keep in mind is the naming of the components that undergo either reduction or oxidization go by the opposite term. So the component that undergoes reduction will be called the oxidizing agent, and the component that undergoes oxidization will be called the reducing agent. So the next part of the lesson will be focusing on balancing redox reactions, and to do that, you'll have to know oxidation states or oxidation numbers. Oxidation numbers are basically a way to keep track of the electron movement in a redox reaction. And to know that, you're going to have to know a few rules. Preferably, you have to memorize these. So for a neutral atom, it will always be 0. And for an ion, it will always be equal to its charge. For fluorine, some elements have their own rules, such as fluorine and chlorine will always be -1. Oxygen has 3 rules. It will most likely be -2. However, if it is in a compound with fluoride, it will be +2. And in a peroxide, such as H2O2, it will be -1. Hydrogen has 2 rules, where if it's in a covalent compound or with another nonmetal, it will be +1. If it's in an ionic compound or mixed with a metal, it will be -1. The total oxidation number for a compound will always be equal to its charge. So for a neutral compound, it will be 0. And for an ion, again, it will be equal to its charge. So in this case, it's going to be -1. The sum of the oxidation number of the components should also be equal to the total. So here we have O2. So oxygen is -2, multiplied by the subscript, which is 2, plus C will be equal to 0. So -4 plus C will be equal to 0. We move the -4 to this side, so it's going to be the oxidation number of C will be equal to +4. Here we have 3O, so it's -2 times 3 plus N is equal to -1 because it's an ion. So this will give us -6 plus N is equal to -1. We add 6 here, we add 6 here, so 5 is equal to N. The oxidation number of N will be +5. In this exercise, we have to determine whether the following reactions are redox reactions. So we have to see if both components have a change in their redox numbers, or oxidation numbers. So since both of these are just pure elements, we know that their oxidation number is 0 for both of them. And here, since it is in a compound, oxygen will be -2, and this whole thing will be equal to 0. So oxygen will be -2 and zinc will be +2, meaning there was a change in the oxidation number of zinc and in the oxidation number of oxygen, meaning this is a redox reaction. Here we have Cl, which is -1, so uh, -1 times 4. So silicon will be +4 since it has to be equal to 0. And in H2O, this will be -2 and this will be +1 since hydrogen mixed with a non-metal is +1. We have the same thing here. This will be -1. Hydrogen will be +1. Oxygen will still be -2 and silicon will be +4. So in this reaction, the oxidation numbers do not change throughout the entire process. So this is not a redox reaction. When it comes to balancing redox reactions, there are two ways. There are two kinds. So the first kind is in an acidic medium, and the second is in a basic medium. Uh, the difference will be explained shortly. So there are 5 main steps, which the first one is to split the reaction into redox half, or into reduction half, and then into the oxidation half. And then for each half, you balance the oxygen by adding H2O. This is step 1. This is step 2. Step 3 is to balance hydrogen by adding H plus. The fourth step is to balance the charge by adding E minus or electrons. The fifth step is to add the two half reactions together and cancel out any repeated elements from each side. However, when it comes to basic medium, there is one extra step where at the end we add OH minus to cancel out the H plus. The H plus. When you add both of these, it will give you an extra H2O molecule, which you will also have to cancel out. So in this question, we're asked to balance the following reaction in an acidic medium. So following the first step, we have to separate this reaction into its oxidization half and its reduction half. So since we know that oxidization is losing, we know that Fe loses an electron, so it becomes Fe2 plus, gives us Fe3 plus. And then the second half will be Cr2O7 2 minus, becomes Cr3 plus. So in the first half, it's pretty self-explanatory since we don't have any oxygen or hydrogen, we just have an imbalance of electrons. So we add 1 electron on this side. Keep in mind that you can only add electrons, not protons. The second part gets a bit more challenging since we have oxygen and an imbalance of charges. So the first thing we have to do is multiply by 2 since we have 2 Cr here and 1 here. So we multiply this by 2. Keep in mind this also doubles the charge, so it will be 6 plus in total. Here we also have to add 7 H2O to balance the 7 oxygen on this side. This will give us 14 H2 or 14 H on this side, which we will have to add 14 H plus on this side to balance. This will make the total charge on this side plus 12, since this is cancelled out and then we have 12 left over. So we add 6 Right here we add 6E minus on this side. And now before we add the two halves together, we have to make sure that there's an equal number of electrons on each side. So we multiply this whole reaction by 6, meaning that 6 will be distributed to each component, which will give us the final answer of 6Fe2 plus Cr2O7 2 minus plus 14H plus will give us 6Fe3 plus 2 Cr3 plus 7H2O. And this will be the final answer. Okay, so in this example, they're asking us to balance the following redox reaction in a basic medium. So we have to keep that in mind. So we start the same way we started earlier by separating it into two half reactions, being Cl2 becomes Cl minus, and NH3 becomes N. So here we first have to balance the amount of Cl, so we add 2 here, meaning the total charge will become minus 2. So we add 2E minus on the side. Here we have to balance the number of, since the number of N is balanced, we have to move on to the H. So we add 3H plus on this side, making the total charge 3 plus on this side. So we add 3E minus. So before we add them, we have to make sure that the amount of electrons is balanced. So here we multiply the top part by 3, and we multiply the bottom part by 2 since 6 is their least common multiple, and we have to get 6 on each side. So we end up with 3Cl plus 2NH3 becomes 6Cl minus plus 2N plus 6H plus. Now we move on to the part that is special to the basic medium, where we have to cancel out the H plus by adding OH minus. So when it comes to OH, it has to be added on both sides. So here we cancel this out first by adding 6 OH minus. And we have to also add 6 OH to the other side, which will give us 3Cl plus 2NH3 plus 6 OH minus gives 6Cl minus plus 2N plus 6H2O. Now, if there was H2O on this side, we would have to cancel it out, but since there isn't any, will be the final answer.